What if I told you that the future of artificial intelligence isn't just about bigger data centers or more complex algorithms? What if the key to unlocking the next level of AI is something as fundamental as light itself? We're on the brink of a massive technological shift, moving from electricity-based computing to something far more powerful and efficient. Quantum light processors. Stick around, because what you're about to hear will completely change how you think about the future of technology. So, let's start with the basics. For decades, our computers, from your smartphone to the most powerful supercomputers, have relied on electrons moving through silicon chips. This is the foundation of digital computing. But we're hitting a wall. As we try to make chips smaller and faster, we run into physical limits. Moore's law, the observation that the number of transistors on a chip doubles about every 2 years, is slowing down. We're generating too much heat, using too much energy, and the physical size of transistors can't get much smaller. This is where the old way of doing things just can't keep up with the explosive demands of modern AI. Now, imagine a different approach. Instead of pushing electrons through wires, what if we used photons, particles of light, to do the computing? This is the core idea behind optical computing, and when you add a touch of quantum mechanics to it, you get something truly revolutionary. Quantum light processors. These processors aren't just a small upgrade, they represent a fundamental leap. Light travels, well, at the speed of light, which is the fastest possible speed in the universe. Using photons instead of electrons means computations can happen almost instantaneously. And here's the best part. Light particles don't interact with each other in the same way electrons do. This means less interference, less heat, and incredible energy efficiency. Think about the massive data centers run by companies like Google and Meta. They consume an enormous amount of electricity, much of which is just to keep the servers cool. Quantum light processors could slash that energy consumption by up to 99%. That's not just a cost saving, it's a game changer for the planet. But how does it actually work? It sounds like science fiction, right? Well, it's very real. Companies are already building these chips. In a traditional AI chip, data is moved back and forth between memory and the processor. This constant shuffling creates a bottleneck, slowing everything down and consuming a lot of power. Optical processors do things differently. They can perform computations directly as the light passes through them. Using a network of tiny, programmable optical components, they can perform complex mathematical operations like the matrix multiplications that are the backbone of neural networks, all in one go. The data is encoded into the properties of the light itself, its intensity, its phase, its polarization. This in-memory computing approach is incredibly efficient. Imagine you're trying to solve a giant maze. The traditional way is like having one person run back and forth, checking one path at a time. The optical computing way is like flooding the entire maze with light simultaneously, instantly illuminating the correct path from start to finish. This parallelism is what makes these processors so powerful for AI tasks, which often involve processing huge amounts of data all at once. And this brings us to the quantum part of the equation. While not all optical processors are fully quantum computers, in the traditional sense, they borrow principles from quantum mechanics to achieve even greater performance. They can manipulate light at the single photon level, unlocking new ways to process information that are simply impossible with classical computers. This allows for a level of complexity and speed that will supercharge AI development. So, what does this mean for you and me? The applications are mind-blowing. First, let's talk about the AI you use every day. Your voice assistants, recommendation algorithms, and even the camera on your phone will become smarter, faster, and more responsive. Imagine having a real-time language translator in your ear that works instantly and flawlessly without needing to connect to the cloud. Or consider self-driving cars. They need to process a massive stream of data from sensors in real time to make life or death decisions. Quantum light processors could provide the instantaneous processing power needed to make autonomous vehicles truly safe and reliable. Beyond our daily lives, the impact will be even more profound. In medicine, these processors could accelerate drug discovery by simulating molecular interactions with incredible speed and accuracy. They could analyze medical images to detect diseases like cancer, earlier, and more reliably than a human radiologist. In climate science, they could create far more accurate models of our planet's climate, helping us predict and mitigate the effects of climate change. For scientific research, from astronomy to particle physics, the ability to process vast datasets in the blink of an eye will lead to discoveries we can't even imagine yet. One of the most exciting aspects is how this technology will democratize AI. Right now, training a large-scale AI model requires access to a massive, power-hungry supercomputer, which only a few giant corporations can afford. Because quantum light processors are so efficient, it's conceivable that the same level of computing power could one day be available in a much smaller, more accessible package. This could empower startups, universities, and individual researchers to innovate and create the next generation of AI without needing a billion-dollar infrastructure. Of course, we're still in the early days. There are significant engineering challenges to overcome. Manufacturing these intricate optical circuits at scale is complex. Developing the software and algorithms to take full advantage of this new hardware is another huge task. It's a completely different programming paradigm, but the progress is astonishingly fast. Startups and major research labs are making breakthroughs every few months, demonstrating chips that are more powerful and efficient than their predecessors. This isn't a distant, far-off dream. This is happening right now. We are witnessing the birth of a new era in computing. An era where the speed of light powers our intelligence. It's a shift as significant as the invention of the transistor or the microprocessor. The transition from electronic to photonic computing will redefine what's possible and reshape our world in ways we are just beginning to understand. The future of AI is not just bright, it's literally made of light. Thank you so much for joining me on this journey into the future of computing. If you found this as fascinating as I do, make sure to hit that like button and subscribe for more deep dives into the technology that's shaping our world. Let me know in the comments what application of quantum light processors excites you the most. See you in the next one.